Welcome to the Businesstalk podcast. I am your host Deepak from India. We are honored to welcome Dr. Douglas Guilbeault, Assistant Professor of Organizational Behavior and Spence Faculty Scholar for the 2025-26 academic year at Stanford Graduate School of Business as our distinguished guest for this episode. Dr. Douglas completed his undergraduate studies at the University of Waterloo, earning dual bachelor's degree in philosophy and rhetoric along with a minor in cognitive science. He went on to pursue a master's degree in cognitive linguistics at the University of British Columbia, followed by a PhD in communications within the network dynamics group at the University of Pennsylvania's Embodied School of Communication. He currently serves as a co-director of the Berkeley Stanford Computational Culture Lab and is a founding member of CompSync, a collective dedicated to research in theoretical cognitive science and machine learning. Dr. Douglas' research has appeared in top academic journals such as Nature, Nature Communications, the Proceedings of the National Academy of the Sciences, and Management Science, as well as prominent media outlets including The Atlantic, Wired, and the Harvard Business Review. His work has been recognized with major research awards from the International Conference on Computational Social Science, the Cognitive Science Society, and the International Communication Association. In this episode, Dr. Douglas Guilbeault shares key insights from his research. Blood is red, math is blue. Does AI see colors like me and you? It is my pleasure to now welcome Dr. Douglas to the conversation. Dr. Douglas, we are truly honored that you have accepted our invitation and delighted to have you with us today.
Thank you so much for having me here. It's a pleasure.
Professor, what initially inspired your research into how people and AI associate colors with abstract concepts like numbers or emotions?
Yeah, so what initially inspired it was this intuition that the way that humans perceive the world is actually much more important to how we think about the world than we realize. So right now, a lot of the AI community is focused on what some call the pure language hypothesis. And so this hypothesis is that what cognition is, what reasoning and thinking is mostly about abstractions that are captured in things like words or things like syntax or grammar. And that just by learning how humans communicate about the world with language, and mostly written language, we can actually learn and recover the core components of the human experience and the human mind. And the pinnacle of that was, since something like 2018 or 2019, there were engineers who would look at AI models trained purely on human-generated text, and they would start to wonder whether the AI was conscious, right? And so this shows this belief that is out there that just by learning language patterns alone, these AI models could meaningfully recreate a human-like experience of the world. But when you stop to think about it, and this is building off decades of research in cognitive science around what's called embodied cognition, and just more generally, an analysis of language reveals that there is so much about our human experience, about the way that we relate to the world and navigate and behave in the world, that is not actually captured by the words that we use to communicate. Because the words that we use to communicate are often simplifications, they are generalizations, they're abstract, but it's mostly because we can get away with communicating this using these sort of simplifications because we already share so much experience between us. So one of my favorite examples is color, because unless you're colorblind, which is itself its own interesting topic we'll get to, but for someone with regular color vision, if you look out into the world, you can see many, many different shades of different colors. Like in my office right now, I can see 10, 12, possibly if I really was careful, I could see 20 or 30 different shades of brown. but I'm not a color expert in the sense that like I'm not an interior designer. So I don't have the names for all these different browns. So I would probably in a conversation with you just refer to it as brown. Um, but we can immediately see that I'm experiencing and aware of many, many more colors than I actually have the words for. And in fact, the average English vocabulary for color words is around 10 to 12 words, whereas we can visually perceive countless different shades and variations of all these different colors. So the question is, like those different perceptual experiences are not getting encoded into the language, and that's just the tip of the iceberg, right? That's just color, right? It shows up in so many different areas of our experience where the language is what some say is doing great violence to reality in the sense of it's leaving out so much information, but it's because we don't have to communicate all that subtlety to get by when we're trying to just interact and solve problems together. But then the embodied cognition perspective, and this is really like what inspired this, because I think the strong response from people in that AI world and just that version of cognitive science would say, yeah, but does that really matter? Does that really impact the way that humans think? And the body of research in what's called embodied cognition, and I can elaborate on that more as you wish, argues that yes, it does matter. That actually the the granularity and the structure and the richness and the experience of these perceptions that humans have, which are not just about pattern detection. They evoke emotions, they evoke memories, they're very powerful inputs into the human mind that they actually do they play an integral role in how we think, and much of the AI world has kind of left that out and assumed you could just skip past all of that and get right to the abstract sort of almost rational like layer of description. And this study was really trying to ask, can you really do that? Does it really work? And so we focused on trying to compare how humans of different color seeing abilities, like can they see color, are they colorblind, or are they like painters, like experts, and compare them to LLM, large language model, AI models trained just on text, and to see do they really think about color in the same way? And can they use color as a construct to reason about new problems in the same way? And that was really trying to focus on this question of, can a language model with just access to text and just the statistics of abstractions in language, can it really reproduce what the humans are doing, where the humans differ basically in that they have all of this other embodied experience stuff? And that's where we found pretty clear evidence, no, but there are interesting connections and similarities between all these different sources that I think are fascinating to explore.
Professor, how did you determine which words and concepts to test for color associations in both humans and AI?
Yeah, so it's a great question. So we focused on a combination of familiar words, so words that are very common in our vocabulary, and then also totally new words and also numbers. And I'll say a bit about why we had these different choices. So one way to think about the problem space that we're in is related to what's called synesthesia. So synesthesia is typically known as a kind of um, niche, almost neurocognitive. It's not quite a disorder because it doesn't really have any dysfunctional properties per se, except in the extreme. But basically, some people, for whatever reason, we still don't really understand it, seem to have really strong color associations between numbers or musical notes or certain words. So famous, composers at various times in history have had very specific color associations with all the different notes on the piano and so forth. So uh, people have built on that and said it's this, and my research team, computational synesthesia team, has been a part of this, is that this phenomenon actually isn't just a niche like neurocognitive uh, novelty that certain people have. It's actually a general capacity. So we can study average folks, like normal everyday folks, who, even though they don't identify as having synesthesia, they can actually make pretty consistent judgments. Now, some of those are already kind of metaphorically present in our language. So we'll say in English, and some of this varies across languages, but in English, there's a tendency to say describe anger as red. And a part of that is because people get red in their face. Not everyone, but some people get red in their face when they're angry. And then we take that and metaphorically generalize it. And so we'll say, like, oh, he or she is seeing red, right? Which is sort of like a metaphor for being angry. So some of that is a sort of color metaphor, but it's already available in the language. So those are the kinds of color metaphors where we would expect it to be learnable from a language model, because there will be ways in which, in many examples and huge amounts of textual data on the internet, that the AI will see anger being associated with red at the level of the words, right? And this is also the argument that has led some people to say, well, colorblind people actually turn out to be quite good at learning these kinds of associations, even those who cannot visually perceive red, because they do learn that whatever red is as an experience, even though they can't have it, they do tend to learn that emotional experiences like anger are described as red. So we included things like emotions, but we also went into domains where our previous research showed that even familiar things that maybe are everyone's has a lot of understanding of, but you might be surprised that they actually still have strong color associations. So things like academic disciplines. So in our prior research, we had showed that uh, the quote unquote harder sciences, I'm not a fan of that word, but like physics, math, computation, they are actually associated with uh, cooler, darker colorscapes like purples and blues, whereas more humanities and arts oriented disciplines like literature, history, and dance, they're associated with warmer color palettes like your yellows and your oranges and your reds. So we know that there's data out there that people can produce this, but it's less pervasive. So there's still a way in which it could be learnable, but it's harder to learn. Now, when you get to numbers, this is where it gets really interesting, because of course we're all familiar with the standard digits, but the rate at which these numbers are described as having colors is again even less, because it's very uncommon that we would have occasion to or need to describe a number as a particular color, like say when doing your taxes or when counting how many bags you need at the grocery store, kind of thing. But nevertheless, it's puzzling. You can ask regular folks, and they have judgments, and they might not even feel confident in them per se. They might not think that they're synesthetic, but you can look across individuals, and in our samples of like English speaking Americans, and there's actually consistency in their judgments around. So as a broader point, we don't know where this is coming from. I have some thoughts I can elaborate on. But that's where it would seem increasingly hard for the LLMs trained just on text to learn those color patterns. But we took it one step further, because so those were familiar domains, but they varied in how much we would expect the associations to be learnable based on the presence and data. But the rubber really hits the road when you start looking at totally new words. So these are there. It's a known construct in psychology. We call them nonsense words or pseudo words, where they follow all of the grammatical or morphological rules of English. They're just a coinage that no one's has ever seen before, like blicker or something like that, right? Now, these are cases where we know almost for certain that there's no training data available. This word has never shown up in the corpus, right? And this is actually where folks who come from the embodied cognition perspective, they want to argue that it's actually those kinds of things, like being able to associate a color with a new word, that humans are especially good at. Because the argument is that part of the reason why humans think so metaphorically, or rather, we're able to, because we think metaphorically. The origin of this is an open debate that I have some thoughts on. But the gist is what metaphorical thinking enables is the ability to think about or talk about things that go well beyond our existing and prior experiences, right? So we can use metaphors to construct entirely fictional worlds. We use metaphors to talk about the future where we can't even measure or observe what's happening. And a nonsense word is an example where we've never seen it before, but we can connect it through various kinds of metaphors and statistical associations to things connected in the past. Now, embodied cognition research would suggest that, say, I give you a word like, let's use glicker, they're going to be, when associating a color with this new word like glicker, there are going to be certain aspects of that that are statistical. So you might bring up words in your mind that are similar, like maybe glean or glare, and those actually have certain color implications. So it turns out in English, the starting of a word with GL, like glean, glicker, glint, it actually has an association with bright light. So it would skew towards that in color space. Or if you think of something like blurred or something like that, people might look at the word, and even though it's not the word blood, it looks pretty similar to blood. And so they would bring up the word blood and assume it's red. But there are going to be some nonsense words where that statistical association alone doesn't give you the answer. There is also, it should be noted, not a right answer here. But and the embodied cognition folks are going to say, or some of them say, that the human ability to perceive color, to associate color with emotions, and to have all kinds of abstract significance associated with color is connected to general capabilities to capture qualities of abstractions that relate to something like how it feels, how, like, what are some of the, like, maybe you've heard of the Bobo Kiki style effects. So this is like a really robust effect in cognitive psychology. If you show people shapes where like one shape is really round and squiggly and the other shape is spiky, if you ask which of these is Bobo and Kiki, with very high likelihood they choose the round shape as the Bobo and the sharp one as the Kiki. And so this is a general human capability to use relatively minimal information, like the shape of a squiggle, and connect it to something like sound to get the feeling of a word. And the argument is our ability to actually perceive reality with feeling is key to that capacity. It's how we develop this capacity and how we use it. That's exactly the kind of capacity that we don't think these LLMs, which are just prediction engines trying to predict sequences of words as abstractions in different syntactic patterns, they don't have access to that kind of strategy. It doesn't just fall out for free from this brute force prediction approach. And so we use these nonsense words to really test, can the pure statistical reasoning approach of the LLMs meaningfully recreate what, for lack of a better word, is a sort of like vibe-based, aesthetic-like reasoning process that humans go through when attaching colors to totally new words. And so that's how we went about choosing the various sets of words to test everything from the most familiar to varying degrees of like learnability, to the wild, unrestricted area where there's no record either for both humans or LLMs to see how they metaphorically connect colors to the stimuli.
Professor, can you explain the distinction between the embodied view and the statistical view in understanding color cognition?
Yeah. So um, a lot of this has to do because we're not really focusing on research about color vision specifically. That's its own Pandora's box that's fascinating. Um, One tidbit I'll share there that I enjoy a lot, which is there was a PNAS paper a couple years ago that was trying to model the human perceptual space of color. So in our minds, which colors are actually close to each other in some sort of representational space. Now, a lot of computer science built for computer graphics has made assumptions around like RGB, hex, and different models, which make various assumptions about like linear similarity and the uniformity of measures, because at the level of building technology, those are really helpful for engineering applications. But it turns out the human perception of color is not that well behaved. In fact, so this PNAS paper shows that the geometry of human perception of color is non-Riemannian, which exhibits forms of non-Euclidean geometry. So like the similarity of colors is not the same based on where you are in color space. The gist there is our perception of color space is surprisingly weird and mathematically complicated in ways that we don't understand. So that alone suggests it's really unlikely for just studying the statistics of words to then, from that, get this really non-trivial, subtle geometry of perception to come out of it. But to your core question, so here we're looking just at words, right? And there was some prior research. So the perspective of statistical reasoning really comes from this view that humans are prediction machines. That the main problem, and they're already kind of baking in assumptions about, why we have cognition in the first place and these sorts of things. But the argument is that the main problem that the brain and the mind has had to solve is how do we predict events and sequences of events and to detect objects as a part of that in order to make behavioral choices or have structured reactions to enable our survival. And the more that you can accurately predict the world, the more that you are able to effectively respond to and adapt to outside events and internal dynamics, which increases survival. I'm glossing over decades and decades of research, but it's a latent theme where now, as our statistical models have become more and more sophisticated, we're increasingly able to describe human beliefs and representations as a kind of Bayesian process or probabilistic, where we can look at objects in the world and say, okay, maybe I'm going to classify a given object with some probability, like that animal is most likely a dog, but maybe it's a cat. I'm seeing it from far away and I'm going to need more information. And so you can describe these sorts of updating processes with statistics. And no doubt some of that is relevant and applies because, statistics is especially general probabilistic updating processes are highly generic. But the question is, to what extent is that the core or fully descriptive of human cognition? And some want to go so far as to argue that that is essentially the core, that the vast majority, if not all, of human cognitive processes at the end of the day come down to statistics being calculated by your neurons at some level, right? And all of this experiential stuff, like your perception of color, your feelings, and so forth, are either just irrelevant, or um, there's a word for it that's eluding me right now. Epiphenomenal. They're just epiphenomenal to this system. Now, a part of that, though, comes back to this tradition, which has started to fracture, where there's a rationalist angle on cognition. So this goes back all the way to Aristotle and Plato, and the analogies that they gave. Notice already they're using analogies, so it's already a bit problematic, right? But they would describe the mind as a charioteer, where the mind is the rational driver of the system and the horses are the emotions, right? And those are just like the chaotic animalistic parts of us, but really the mind is this controller of the system, right? And that baked in this framework where for quite a long time, and it still shows up today, people view things like reasoning and rationality as fundamentally distinct from emotions and feelings and sensations, and that ultimately studying cognition, like in terms of abstractions and reasoning and problem solving, is studying the rational part, and the emotion stuff is just some uh, byproduct of our biological evolution that gets in the way, if anything, of clear reasoning, and just kind of noise in the system. But that's started to come under serious doubt, in part because of decades of work. DiMaggio was one among several, which showed that actually human emotions and feelings uh, are actually essential to effective reasoning. So people with brain damage to their emotion parts of the brain, but still have their reasoning capabilities intact, end up making terrible decisions. They can't solve problems. They can't prioritize, and so on and so forth. There's many, many examples of that. And the embodied cognition literature is in conversation with that and builds on it by showing things like um, when your brain actually processes sentences, when you look, even though we're still very far from understanding how the brain works and how these things are implemented at the level of neurons, but that when you're actually trying to capture in terms of like which brain regions or networks of brain regions are involved in processing particular sentences, there is strong evidence that's been replicated and reproduced through various different studies and paradigms that the brain actually activates areas of the sensory motor cortex that correspond to the perception of those things. So if I tell you a sentence like the boy is riding a sled down the hill in the snow, your brain seems to, on the current theory, activate to some approximation a simulation of that sensory experience. Now, it's unlikely to be a full-blown, like movie-like simulation. Not everyone has equal access internally to that kind of mental imagery. But it could very well be a kind of like simplified implementation of it. The way that like when dancers practice their dance, they don't do the whole dance, they just do slight micro movements to rehearse that kind of thing. But I bring that up because it's also, if you look at, say, the way that humans communicate when we're speaking orally, things like our gestures with our hands and our eye gaze and our facial expressions, they're all intensely coordinated in ways that are not intentional or deliberate. And you look at the brain and the areas of the sensory motor cortex that are responsible for coordinating our bodily movements have like a superhighway with language areas and the parts of our brain that generate speech. And it turns out if you prevent people from moving their bodies while they talk, they become less fluent. There's all kinds of ways in which you can show that the real-time sensory information that's involved in our perception and communication is directly interacting with and shaping our generation and interpretation of language, both orally and in text. And so this isn't to say that the embodied cognition is totally the opposite of the statistical approach. They're often quite open to there being aspects of human cognition that are described by statistical reasoning. They just push back about whether that is all inclusive of a cognitive model, because it's not simply that they would say there are things like perception, sensory experiences, sensory motor coordination, um, that are involved in language and cognition, but that we're actually quite far from understanding computationally how they work. And this is where the question of metaphor becomes very interesting, because oftentimes, if you look at the content of our language itself, we use metaphors all the time to think about problems. And so one question is, why are we so metaphorical? So in English, and this prevalence of metaphors is universal across cultures. To my knowledge, there has been no language discovered and characterized that lacks these metaphors. The specific metaphors vary, but the pervasiveness of metaphor itself. And what metaphor essentially is, the structure of it, is taking, and this is characteristic of human metaphor and analogies, is we take concepts from our embodied experience, something concrete like a feeling, an experience, something spatial, something sort of down to earth and concrete and grounded in our world, to talk about something abstract that we can't perceive. And so one example is ideas. So we say like, oh, I grasped that idea, or let me unpack that thought. And what we're talking about is ideas as this sort of object that we can hold, that we can unpack, that we can take into parts, that we can decompose, that we can construct arguments the way that we construct a building. So we simulate some world where ideas are like physical objects we can interact with. But in many ways, they're not. Or our ability to interact with them in a quasi-physical way like that is because we're metaphorically framing them that way. But how that works is not in any ways easily explained by a statistical process, because it's not simply about using past data to predict future data, because it's actually going through quite a different modality of prediction, because you're actually having to adopt this unusual strategy, which is I'm going to take something from the past and I'm going to think about it in a totally new way, in a way that in some ways is departing from the reality, right? Like when I talk about numbers as having colors, the numbers don't have colors in essence, right? Like there's nothing in the world that I could look at, say like, oh, or with the nonsense words, there's nothing in the world I could look at experientially that would tell me. But I can have this metaphorical reasoning process about it evoking all kinds of peripheral or adjacent things, and then I can come up with a connection among those ideas. Um, so that's one way to sort of frame this tension, this conversation between the embodied cognition and the statistical point of view.
Professor, what surprised you most about the tendency of both typical and colorblind participants to select similar colors for abstract ideas?
Yeah, so, well, what surprised me about that was, so there was quite a lot of research which showed that colorblind and color impaired vision, because quite a few people who we studied that were colorblind actually have some version of color experience. So there was only some that actually are completely color blind. But there was research showing that these color impaired and colorblind people could still learn surprisingly accurate judgments about color words in English language and everyday language from the statistics. And that's not that surprising. It's interesting, but it's because those color words are used frequently. So, they would learn that like blue and green are closer together than blue and red. they would learn, even if they can't see what colors things are, they would learn that grass is green because grass is described as green, right? Now, that's very different than, oh, but they've basically learned what the color green is. And this is where it's an ongoing philosophical debate, and the experiment with, there's a famous thought experiment about a scientist who basically is obsessed with color theory and studies color, but spent her entire life in like a dark room and is learned everything there is to learn in textbooks about color. And then after having digested all this abstract information about color, then goes into the world and sees red for the first time. And the question is, has the scientist learned anything from seeing red? And there's a whole theme in research on cognitive science and consciousness, which they really want to be deflationary around that and say they don't learn anything. It's just uninteresting. This thing, they would call it qualia, or the qualitative experience of color. It's just not that interesting. And I just fundamentally disagree. I think that is trying to trivialize something that is just way too complex for us to understand at this time, as a solution to handling the puzzle of it. So I won't go all into the color theory stuff, because then of course you can break it down into wavelengths, but it's not just about wavelengths, because there are contextual interactions in terms of which colors show up with each other. But the gist is that the colorblind people in particular, that the thing is they don't ever get to have that moment of that scientist, especially the extreme cases. They don't ever get to see the red. So the question is like, well, they're learning color associations, but do they really have the full picture? Do they really get something about what there is to experience color? Now, what we found in our study was that, like, if it was true that the colorblind people were just learning color associations in words, then they should have looked a lot like the LLMs when they're starting to associate colors with things for which there isn't a lot of data out there for statistical associations, like numbers or nonsense words. Because again, that's where the available statistical data is breaking down. So they can't solve it just through a prediction problem per se, or that's the argument. But it turns out, even in those cases, the colorblind people are a lot more similar to the color seeing people than both are to the AI. And so what was surprising about this, and this is where I think it's an important contribution we've made, is that prior work, which looked at the achievements of colorblind people at learning color language, they emphasized and attempted to explain it with respect to the statistics by saying, oh, they are able to do this because colorblind people have just as well functioning statistical reasoning processes as the average person. So they solve it that way, and it was taken as, in some ways, support for the statistical characterization of human cognition, and look how powerful statistics is. But I think that the ability for the colorblind people to achieve these even more metaphorical and abstract similarities of color reasoning than humans is not explainable by the statistics alone for all the reasons I described before. And if you really think about it, it's because, or I think one compelling consideration here is we're really oversimplifying human colorblind visual experience and embodied experience in general by saying, oh, it's just statistical. Now, there's no doubt that they're learning statistical patterns in language. Everyone is. That's just if you're learning language. But the human colorblind participants still have intensely vivid embodied visual experiences. Many of them either have some few minimal colors, or even in grayscale, there's still highly varied and continuous and gradated visual perceptions of distinctions. And actually, there's some work, including by famous portrayals by Oliver Sacks and others, suggesting that actually those who are colorblind, either were born with colorblind or then become colorblind through brain damage, actually like intensify their depth perception, especially at night, because ways in which their vision is actually more adapted to those settings. So, but even beyond that, there's no way in which the emotional universe of the colorblind people is impaired, let alone their body movements, their scent, their smell, their taste. There's, except for individual variation, the assumption is they're basically the same as the color seeing people in every way, except their color vision is impaired in some sense. And the thing about embodied cognition and perception is everything's entangled in a way. So a lot of our metaphorical reasoning, and our perceptual representation of the world is multimodal. So our vision and our hearing and our body movements are all exquisitely coordinated with each other. And there can be all kinds of leakage or transfer of concepts from one domain into the other. It's why we talk about colors as being warm or cold, or we talk about musical notes as being sour or sweet. You don't taste a musical note directly, but there's a way in which it makes very clear sense. We can communicate rich information by talking about music as having taste. So there's a lot of research showing, I'm not, I'm having to summarize quite a lot quickly. There's a lot of research showing that uh, there's enormous amounts of information in how we represent one sensory experience that's encoded in our representation of another sensory experience. And that may very well be essential to the experiential richness of human mental life, is this multimodality. And there's lots of people who take that very seriously, both in their theorizing and in their empirical research. And so it may very well be that a part of what enables these colorblind participants to be surprisingly similar to color seeing participants in these more metaphorically demanding association tasks is by leveraging things like emotional associations or other kinds of metaphorical associations in order to solve these kinds of new metaphor association problems. And we have evidence for that. We have a survey where we also show people uh, new color metaphors, and we actually have them not just provide their interpretation, but their explanations for their interpretations. And then we encode, like, to what extent do they evoke embodied experiences and aesthetics as a part of their explanation versus just statistical reasoning and other strategies. And we find that the colorblind and color seeing people are really strongly using a lot of embodied arguments. So the colorblind people in some ways are no less embodied in how they think about these problems. And actually, the LLMs in those cases were the least likely to use embodied reasoning strategies and skew towards the statistical reasoning approach, which is what we would expect, but it also helps us explain the deviation um, between the LLMs and the colorblind, that it seems to be along the lines of the colorblind are still engaging in some combination of statistics and embodied reasoning where the LLMs are doing so less. And then in that survey, the people who were most sensitive and most intensely engaged with embodied reasoning were the painters. And this is cool because the painters actually in their daily life are literally more engaged in an embodied way with the use of color to represent abstract ideas. And this is where I think that's part of why this argument that qualia doesn't matter, it seems untenable to me, because we have countless people who spend their lives devoted to the use of these qualitative experiences to express things of enormous personal and existential significance for themselves and others culture. So,
Professor, in your view, would training AI on visual data such as images or video fundamentally change its ability to mimic human associations with color?
It's a really great question. I would say I think it's quite possible in the long run we could get something like that to provide really valuable insights. And I think that the direction towards multimodality in general as a theoretical approach is essential toward capturing some of the human approach to representing the world. However, I don't think the engineering dominated approach in AI is at all on track to do that in a theoretically accurate and sophisticated way. The current approaches to multimodality are much more skewed toward just how to extract predictive relationships in a co-occurrence sense between images and videos and words. And a lot of the time it involves under the hood converting images and videos into quasi-textual representations by looking at the ways in which that content is tagged and the metadata, or breaking images down into sequences of pixels that don't in any direct way reflect how humans actually perceive. Like we don't perceive pixel values, let alone, you know, discrete sequences of pixels in different combinations. And in fact, we have research in the Journal of Cognition showing that off-the-shelf computer vision classifiers of images, it's not simply that they don't really perceive color in a way that resembles humans, but they don't seem to really perceive color at all. These deep learning networks seem to readily drop color information relatively early on in their training process and skew much more towards abstract statistical patterns. And that is very much likely to dominate the current approaches to multimodality, which are all scale dependent. So it's a lot of it's like a kitchen sink style approach where you're just putting tons of images, tons of videos, and tons of text into some massive, multi-layered deep learning network where you're just trying to establish connections to them using really high dimensional statistical patterns. And our research and the research of many others suggests that in the process of trying to identify those high dimensional statistical patterns, these models quite often drop a lot of the sensory perceptual information and get much more towards just a sort of optimization loss function approach towards certain complex geometries or shapes in an abstract, high dimensional space. And there's just evidence, there's quite a lot of evidence that while some part of that, something like that, though very far from the same thing in detail, but certainly processes of abstraction are highly characteristic of human cognition. But that coexists with, is in balance with all kinds of highly real-time sensory rich information that is not dropped. It's not locked. That's the thing about like as a normal color vision seeing brain, we have all these abstract concepts. Like I can categorize this as a mug. I can categorize your glasses on your face and all these things. But I also see the color of your glasses. I see they're black glasses. I see my mug. I see my jacket. And so clearly in the development of these abstractions, we have not abandoned the color experience. In fact, we have what seem to be incredibly rich and intense and immediately available sensory experience in our consciousness alongside available abstract classifications and categorizations of that sensory information. Whereas the current approaches to AI, in order to achieve those abstractions, they often go through a process where it's no longer in conversation with the raw and continuous sensory-like representations. And it's, I think, a key part of the multimodality. And again, there's so many more things to be done, but not only is it that those layers need to not be separated, like they coexist in human cognition, but then as an additional step, when we are integrating information from these different modalities, it's quite likely that the human mind does so through some metaphorical and analogical process that we're still far from completely understanding, certainly within a computational perspective. But that is not what seems to be happening, or at least does not seem to be meaningfully recreated by just this brute force deep learning approach where everything's mashed together into some high dimensional space. I don't think that the kinds of metaphors, I don't think they're generating metaphors and analogies of that nature at all. But even if they were to, and maybe at some point we'll end up, although it would be an analogy itself, describing them that way, I don't think that's going to be similar to how the humans are doing it. And that's not simply just at the individual mind. I mean, our brain is highly specialized. So we have all these sensors. There's just so much structural constraint in the human brain and what's happening there. But we also do it socially. We interact in the language that we use. Part of the driver for metaphor is also the fact that we have to connect our own experiences with each other in ways that, like, I can't know what's happening inside your mind and vice versa. So we use metaphors to triangulate and approximate that. Um, and that's also completely separate from a lot of how the current approach to LLMs are trying to learn these multimodal associations.
Professor, I would like to conclude this episode with one last question. What open questions or future directions does this research point to regarding the intersection of AI, human cognition, and sensory understanding?
Yeah, so I think this is a great question. One thing I want to emphasize is that, so even though our paper showed that there are many ways in which the LLMs uh, do not reproduce the kinds of color associations that humans produce, including in some of the familiar domains, but especially in the nonsense words and new domains. Um, Something that is striking, though, is the LLMs did have strong color associations for these concepts. And I think one really important direction for future research is why. Why, even for the nonsense words, they were different from the humans, but the AIs provided stable and consistent color associations for novel words. Sometimes that could be explained by features of the word, like it could get the statistical associations of describing, words like Blortimer as red because it looks like blood. But there are also nonsense words where it wasn't obvious that there was an available statistical uh, uh, transfer happening, but it would nevertheless was developing really stable and strong color associations. So it seems to be the case that LLMs, through no direct intention of the designers, have acquired or developed some form of synesthesia. So, if anything, this suggests how recurring it is for cognitive systems, vaguely, roughly, generally described, to develop a synesthetic-like way of connecting concepts. We know that this is highly characteristic of human cognition, and we're just starting to understand how general and broad that is. But what's fascinating and what I think is really powerful and why it's so, this has basically been largely neglected, or there's very little research on treating synesthesia as some foundational structure or a key unlock in understanding the way in which embodied sensory experience plays a role in our development of abstract cognition and reasoning. But I think it is in some ways like the model organism for one of the simplest ways in which there's an interface between a sensory layer and an abstract set, like color applied to numbers or to concepts, right? And one of the things that I think synesthesia enables, and this is where I think it's key to something like the highly creative, generative, and flexible cognitive capacity that humans have, is it allows for concepts from very different domains to have a strong mapping, a pathway between them. So we know one of the things that enables humans to be really creative and flexible in their cognition is the ability to get from one concept to another through very few steps in a network sense. It's like a 6 degrees of separation kind of thing, right? Like in a conversation, we could start by talking about dogs, and in 3 minutes, suddenly we're talking about politics, and in 4 minutes later, we're talking about the Olympics, and suddenly we're talking about our favorite kinds of coffee. So there's like a fluidity in topic space, and metaphors play a key role in that because we can be talking about something like, uh, you know, the sound of our favorite musician's voice, and we're using color to describe that, like bright or dark, right? um, so we're then mashing together concepts from totally different areas of conceptual space on a very regular and familiar basis. And I think that that mashing together is actually far more characteristic of human cognition than is realized. And the fact that the AIs, even through, I think, a very different kind of approach, I don't think they're developing concepts or reasoning in ways that are similar to humans, but even a purely statistical approach is already stumbling upon synesthesia. And it's sort of like it has no business doing that, but it's already doing it, which suggests in some computational space it's a really strong attractor. And I think there's just a really valuable question for future research to understand what role does synesthesia and this sort of like mashing together of concepts from totally different domains play in language, in our model of the world, and in thinking more generally.
Listeners, thank you for joining us for this enlightening conversation with Dr. Douglas Guilbeault. Today, Dr. Douglas shared key insights from his pioneering research. Blood is red, math is blue. Does AI see colors like me and you? Exploring how humans and AI interpret color and what this reveals about nature of cognition. We appreciate Dr. Guilbeault's fascinating perspectives on the relationship between language, sensory experience, and artificial intelligence. If you enjoyed this episode, please subscribe, leave a review, and share it with your network. Stay tuned for more thought-provoking discussions with leading minds in academia and business. Until next time, stay curious and keep exploring new ideas. Thank you, Dr. Douglas Guilbeault. It's been a truly pleasure having you with us today. Thank you so much.
Thank you very much. I enjoyed it a lot. Take care.
Thank you.